Today we're going to start taking notes on the flipped classroom model. Before we actually start our Unit 3-2 notes, we need to talk about a couple of materials that you'll need in front of you before you start the video. You're always going to need to have in front of you the notes, which are shown here below. If the notes aren't given to you in a packet or on a worksheet, then you're going to definitely need to have your notebook in front of you. You'll need a writing utensil, whether it's a pen or a pencil, whichever you prefer. And you'll also need a graphing calculator in front of you because there'll be some problems that you're actually going to have to do the calculations on your own that can't be shown on a video. Okay, with that being said, we're going to start today's notes on 3-2. There are two warm-up problems. What I want you to do right now is pause the video, complete the two warm-up problems because they're a review from your algebra days, and then come back and let's see how well you did. All right, hopefully you remember that when you're multiplying radicals, you multiply the outside guys, then the inside guys, and then simplify. So in this case, I'm going to have 12 radicals 75. And 75 can be simplified to 25 times 3. Square root of 25 is 5, meets the 12, so I'm going to end up with 60 radical 3 as the final answer. And hopefully that's what you've got. Squaring means to multiply something by itself. So that's basically what I'm going to do with number 2. I'm going to multiply the outside guys and then the inside guys. Okay? So I'm going to end up with 49 radical 9. Square root of 9 is 3. 3 meets the 49, and I end up with 147. So that's just a little review of multiplying radicals. We're going to multiply and divide radicals today, again, that are binomials. Any two numbers in radical form can be multiplied or divided when the indexes are the same. Multiply and divide the coefficients, and then you're going to multiply and divide the radicands, and then you're going to simplify. All right, we have a couple examples we're going to go through to do this. The first one is, for number 1, it says multiply and combine like terms, then explain what you notice about the two different results. Okay, for number 1, we have two problems to do. So the first one's a binomial times a binomial, so we're going to do double distributive property. I'm going to end up with radical 9 plus radical 6 plus radical 6 plus radical 4. I'm going to simplify. The square root of 9 is 3. Radical 6 plus a radical 6 give me 2 radical 6s. Square root of 4 is 2, and it's a plus 2. It's a lousy plus, sorry. Combined like terms, I'm going to get 5 plus 2 radical 6 is my final answer. So I ended up with a binomial. Let's take a look at the second two binomials that we have to multiply here. So radical 3 times radical 3 is going to be a radical 9. Radical 3 times a negative radical 2 is a negative radical 6. Positive radical 2 times a positive radical 3 is a positive radical 6. And a positive radical 2 times a negative radical 2 is a negative radical 4. Square root of 9 is 3. The radical 6 cancel each other out. Minus the square root of 4 is 2. So my final answer here is 1. So if you take a look at this actually was dots. And when I multiplied by dots, the 2 in the middle, when doing double distributive property, canceled out. So I no longer have a radical. Let's take a look at that a little further with number 2a. Find the product of the conjugate radicals. Conjugate means that the first binomial and the second binomial look exactly the same. The only difference is one would be a plus and one will be the minus. So they have opposite operations. So again, we know that's called dots. Difference of two squares. So when we multiply these guys, let's see what happens. I'm going to get a radical 25 minus radical 15 plus radical 15 minus a radical 9. Simplify, 5, cancel, minus 3. My final answer is 2. So again, when I multiplied a binomial by its conjugate, which I did dots to, the two terms in the middle canceled out, I no longer have what's called a radical. So there's a way of getting rid of a radical. I think we have one more on this page to take a look at. Let's do number 3. I'll get 49 minus 7 radical 2 plus 7 radical 2 minus radical 4. 49 comes down. The middle guys cancel out. Square root of 4 is 2. I end up with the final answer of 47. So again, I multiplied by the conjugate of the original, and I ended up with no radical. On page 4, we have letter C to do. Why don't you do letter C by yourself? Pause the video and come back and see how well you did. All right, hopefully for letter C, you ended up with radical 25 minus 2 radical 5 plus 2 radical 5 minus 4. Square root of 25 is 5. The middle guys cancel out. Minus 4. The final answer is 1. So hopefully you're realizing that every time you do double distributive property to two binomials that are conjugates of each other, the two terms in the middle will cancel out. And now we know that when we have radicals and multiply by the conjugate, the radicals will cancel out. We no longer have a radical. All right, number 3 says, write the following in simplest form. Well, there's a radical in the denominator, and we're not allowed to ever have a radical in the denominator. So whenever you have a radical in the denominator, the rule is to multiply by its conjugate to get rid of the radical in the denominator. Well, in this case, the original is 5 minus 2 radical 3. So let's rewrite the problem. And we're going to multiply the denominator by the conjugate, which would be 5 plus 2 radical 3. But the rule is, whatever you do to the bottom of a fraction, you have to do to the top. So let's see what happens here. On the top, it's just distributive property, and I'm going to end up with 5 radical 3 plus 2 radical 9. And on the bottom, I'm going to end up with 25 plus 10 radical 3 minus 10 radical 3 minus 4 radical 9. Because remember, you multiply the outside guys and the inside guys. So on the top, I'm going to end up with, see, the square root of 9 is 3. So this is going to be 5 radical 3 plus 6. And on the bottom, I'm going to end up with, these guys cancel out, 25 minus square root of 9 is 3 times the 4 gives me 12. Let's neaten this up. 5 radical 3 plus 6 over 13. Now I've got to check all my leading coefficients, 5, 6, and 13. Can they be reduced by anything? No. So I'm done. All right, let's do one more. Radical 7 plus 1 divided by radical 7 minus 2. So I'm going to actually rewrite it as a fraction. So radical 7 plus 1 divided by radical 7 plus 2. I have a radical in the denominator. Let me get rid of that. I do have an eraser here. Yep. So I want to get rid of the radical in the denominator because I'm not allowed to have it because I can't divide by a radical. So I'm going to multiply it by its conjugate, which will be radical 7 plus 2. But whatever I do to the bottom, I have to do to the top. And let's see what I end up with. Okay, so I'm going to end up with radical 49 on the top. Oh, I'm going to have to do double distributive property, and it's not conjugate, so I'm just going to have to take my time. So I get radical 49 plus 2 radical 7 plus a radical 7 plus 2. On the bottom, I end up with radical 49 plus 2 radical 7 minus 2 radical 7 minus 4. Neaten it up. On the top, I'll end up square root of 49 is 7 plus 2 gives me 9 plus 3 radical 7s. And on the bottom, middles cancel out. Square root of 49 is 7 minus 4 gives me 3. Now I'm going to take a look at all my leading coefficients. They all can be reduced by 3, goes into 3 once into 3 once, into 9 3. So my final answer is going to be 3 plus 1 radical 7 is just radical 7 over 1 is 3 plus radical 7. So there's my answer. So if I can reduce, looking at all my leading coefficients, I'm supposed to. So again, you can't have a radical in your denominator. So what you have to do is you have to eliminate it, and if it's a binomial, you're going to multiply by the conjugate. Well, let's take a look at what this information is saying to you here. Whenever you have a radical times a radical, and they're both underneath each other, you can actually split it to be a radical A times a radical B. And if you're dividing, you can also actually split up the division to have a radical over the top and a radical on the bottom. I know this is hard to see. This should say radical A divided by radical B. And it's the same thing when you're actually cube rooting. It's the exact same thing. Then it says on this third bullet here, two binomials in the form of radical A, and that should be a plus B. Let's make that a plus. And radical A minus B are considered to be conjugates. They're opposite operations, and that should be a plus. So when you have radical A plus radical B, the conjugate would be radical A minus B. And when you have radical A minus B, the conjugate is radical A plus B. So it's basically showing you the conjugate. Now if you have one radical only, and it's 2 minus radical 3, the conjugate would be 2 plus radical 3. And we've gone over conjugates. And this should be a plus down here, and this should be a minus here. So a way to eliminate the radical in the denominator is to multiply by the conjugate, especially if it's a binomial. But whatever you do to the bottom, you have to do to the top. So that takes care of the notes today. If there's anything you're unclear of, go back, replay the video for yourself so you can clarify it a little bit more. If not, please ask any questions you need to tomorrow in class.